awesome.
The night sky above our world is littered with diamonds, each one a burning sphere of plasma, suspended across the void by nothing more than gravity and time. To the naked eye, the heavens may appear as a simple scattering of lights, but hidden within the darkness lies a colossal neighbor, larger than any single constellation, a structure so immense that it humbles every notion of scale. Its name is Andromeda. And though it resides 2.5 million light-years away, it is not a distant stranger. It is our galactic partner, our future dance partner in a cosmic waltz that will one day reshape the very architecture of the night sky. Tonight, we embark on a journey into its heart. Andromeda is the closest spiral galaxy to our own, a mirror and yet a mystery. Stretching more than 220,000 light-years across, it dwarfs the Milky Way, its luminous spiral arms sweeping outwards like the brushstrokes of a cosmic painter. Within those arms swirl hundreds of billions of stars, each with its own story, its own lifetime, and perhaps, its own worlds. If you could stand upon some silent rock floating just outside its halo, Andromeda would dominate the sky. Its breadth would span several times the diameter of the moon, a glowing island of light against an ocean of darkness. To begin our voyage, we drift toward its outskirts. The halo of Andromeda is not empty. It is a realm populated by globular clusters, ancient spheres of stars, tightly bound and billions of years old. These clusters are the fossils of galactic formation, witnesses to an era when galaxies were young and violent, when collisions and mergers were not rare events but the very mechanism by which the universe built its structures. In these globular clusters, stars are crammed so densely that from the surface of a hypothetical planet within them, the night sky would never be dark. Hundreds of suns would paint the heavens in constant brilliance, making shadows eternal and the very concept of night a myth. Passing inward, we cross the galactic disk. Here, the spiral arms emerge in grandeur. Blue-white stars blaze at their prime, massive, hot, and short-lived. They are the aristocrats of the cosmos, spending their fuel in a furious race toward oblivion. Around them, clouds of gas and dust shimmer in pink and red hues, nebulae where new stars are born. These stellar nurseries are the incubators of galactic life, churning out suns that may last for billions of years, some destined to host planetary systems not unlike our own. It is within such clouds that hydrogen atoms, the simplest and most abundant matter in the universe, find companionship, fusing into helium under the crushing weight of gravity. In doing so, they ignite the engines of light and heat that will illuminate the galaxy for eons. Deeper still, the density of stars increases. Here, golden populations dominate. These are the elder stars, smaller and cooler, yet enduring. Unlike their massive blue counterparts, they burn with patience. Many of these suns are older than our Earth itself, predating our solar system by billions of years. Around them may orbit worlds that have had eons to evolve. One cannot help but wonder, what civilizations might have risen beneath the light of these ancient suns? And what stories, if any, do they tell of their place in this galaxy? As we approach the core, the stars become a blinding swarm, their light merging into a continuous glow. The nucleus of Andromeda is a crowded theater of gravitational forces, where orbits twist and loop under the influence of invisible giants. At the center resides a supermassive black hole, tens of millions of times the mass of our Sun. It waits silently, a gravitational monarch ruling over the inner galaxy. Around it, stars whirl at breakneck speeds, some flung away, others devoured. The black hole does not shine, but its presence is betrayed by the radiation of matter spiraling into its event horizon, heated to incandescence as it falls toward a fate of no return. Yet Andromeda is not static. Like every galaxy, it is alive with motion, a vast organism shaped by the physics of dark matter and the inexorable flow of time. Its spiral arms are not fixed structures but patterns of density waves, where stars and gas bunch together temporarily before flowing onward. It is a traffic jam on a galactic scale, where the congestion of matter triggers new bursts of star formation. And in the outer regions, satellite galaxies orbit Andromeda like moons around a planet. Some are destined to be absorbed, their stars stretched into tidal streams, their identities dissolved into the larger whole. This journey is not just an exploration of Andromeda, it is a reflection of our own fate. For the Milky Way and Andromeda are on a collision course. In 4 billion years, their paths will cross, their shapes distorted by tidal forces, their stars rearranged into arcs and bridges of light. From a distant vantage point, it would appear as a cosmic ballet, two titans of starlight weaving together into one. For Earth, should it still exist, the night sky will become a spectacle unimaginable. Andromeda will grow larger with each passing million years, until it fills the heavens in a breathtaking confrontation. And when the merger is complete, a new galaxy will emerge, Milkdromeda, a giant elliptical galaxy that will carry within it the legacy of both ancestors. As we float in imagination within Andromeda's luminous arms, we are reminded of a profound truth. Galaxies are not merely distant pinwheels of stars, they are living chronicles of cosmic history. Each one contains the memory of creation, of destruction, of transformation. To journey into Andromeda is to journey into the essence of what the universe is, restless, beautiful, and boundless. And though we cannot yet send spacecraft across such vast distances, we carry within our minds the ability to travel there. Through telescopes that peer deeper than eyes could ever see, through equations that decode the language of gravity and light, we become voyagers without leaving our world. The Andromeda Galaxy is not an unreachable dream. It is a destination already mapped in our imagination, a reminder that our small blue planet is not isolated, but part of a vast cosmic neighborhood whose stories are waiting to be told. And so, as our vision fades from Andromeda's brilliant core, we return home with new perspective. The universe does not merely surround us, it defines us. We are its children, born of its stars, destined to one day meet our galactic sibling in a union written into the very laws of physics. Until then, we look up, and we wonder. When we think of Andromeda, we often imagine its sweeping spiral arms or the sheer scale of its disk. Yet hidden beneath that familiar image lies a deeper story, one written not only in light but also in shadows, radiation, and invisible matter. Our journey continues, peeling back the layers of the galaxy to reveal structures and phenomena that no eye alone could ever capture. Beyond the glittering stars lies the interstellar medium, a tenuous ocean of gas and dust stretching across Andromeda's vast disk. It is here that the cycle of stellar life truly unfolds. Supernovae scatter the heavy elements forged in their cores, seeding the galaxy with carbon, oxygen, iron, and gold. Shock waves ripple outward, compressing clouds of hydrogen until gravity takes hold once more. A star dies, and in its ashes another is born. This recycling of matter is the heartbeat of the galaxy, ensuring that no atom rests forever, but instead becomes part of new worlds and perhaps, new forms of life. Among Andromeda's treasures are its nebulae, immense regions where starlight ignites curtains of gas into glowing mosaics. Some are emission nebulae, where ultraviolet light from newborn stars ionizes hydrogen, causing it to shine crimson. Others are reflection nebulae, where dust scatters the light of nearby stars, painting clouds with a blue glow. And still others are dark nebulae, cold and dense, obscuring the stars behind them like cosmic silhouettes. Together, they form a canvas as dynamic as any storm on Earth, but operating on scales that stretch for dozens or even hundreds of light-years. The stars within Andromeda do not all shine alone. Many belong to binary or multiple systems, pairs or trios locked in eternal orbit around one another. Some of these binaries are ordinary, their partners circling with steady grace. Others are far more exotic, systems where one star has collapsed into a neutron star or black hole, siphoning matter from its companion. As the stolen gas spirals inward, it heats to millions of degrees, unleashing X-rays that pierce across the galaxy. To our telescopes, these X-ray binaries are beacons, revealing not only the presence of collapsed stars but also the violent intimacy of stellar evolution. Andromeda is also home to phenomena invisible to human senses, magnetic fields threading its disk, shaping the motion of cosmic rays. These high-energy particles, accelerated by supernova remnants and other energetic events, stream across the galaxy at nearly the speed of light. They weave through magnetic filaments like sparks in a storm, influencing star formation in subtle yet profound ways. Though we cannot see them directly, we detect their presence through radio telescopes, instruments that convert whispers of the universe into data, and data into insight. But perhaps the most enigmatic feature of Andromeda is the one we cannot see at all: dark matter. Observations of its rotation reveal a paradox. The stars in Andromeda's outer regions orbit far too quickly to be held in place by visible matter alone. Something unseen exerts gravity, forming a vast halo that outweighs all the stars, gas, and dust combined. Dark matter does not glow, does not scatter light, and does not interact with ordinary matter except through gravity. Yet it dictates the architecture of galaxies. Without it, Andromeda would fly apart; with it, the galaxy holds together, a silent testament to a cosmic substance we barely understand. In studying Andromeda, we are studying not only another galaxy, but the very scaffolding of the universe itself. Supernovae punctuate this galactic story like exclamation marks. When massive stars reach the end of their lives, they collapse and explode, releasing more energy in a single moment than the sun will emit in its entire lifetime. The light of such an explosion can briefly outshine the combined brilliance of billions of stars. In Andromeda, supernovae have been observed throughout history, visible even to the unaided eye across millions of light-years. To ancient sky watchers, they were omens. To us, they are laboratories, revealing the physics of matter under conditions impossible to replicate on Earth. Chemical enrichment is their legacy. Every atom heavier than helium in your body, carbon in your cells, calcium in your bones, iron in your blood, was forged in a star that lived and died long before our planet was born. In Andromeda, this process unfolds across billions of stars, scattering the ingredients of life into interstellar clouds. If we could trace the atoms of a distant world orbiting a sun-like star in Andromeda, we might find the same periodic table that builds us. The galaxy is not only a system of stars, it is a crucible of chemistry, repeating the same cosmic alchemy that made Earth possible. Andromeda's globular clusters add yet another layer to its story. Some contain hundreds of thousands of stars, all born at nearly the same time, billions of years ago. They are galactic time capsules, preserving the conditions of the early universe. Studying them reveals how the first generations of stars shaped galaxies, enriching them with elements that paved the way for planets and biology. In some clusters, astronomers detect exotic objects like millisecond pulsars, neutron stars that spin hundreds of times per second, emitting beams of radio waves like celestial lighthouses. They are the relics of ancient cataclysms, still echoing across space. Venture further inward, and the density of stellar populations grows extreme. The bulge of Andromeda, surrounding its central black hole, is a crowded city of suns. Orbits intertwine, and gravitational interactions can fling stars from the core at hundreds of kilometers per second. Some of these stars are hurled into intergalactic space, becoming homeless travelers drifting between galaxies. Each of them carries the signature of Andromeda, fragments of a system far larger than themselves. Yet even in this crowded galactic metropolis, mysteries remain. Astronomers have discovered double nuclei in Andromeda's core, an unexpected structure where two dense clusters of stars seem to orbit the central black hole. The reason for this peculiar formation is still debated. Some believe it is the remnant of a smaller galaxy consumed by Andromeda, its heart preserved even as its body was absorbed. Others think it is an illusion created by a torus of stars spiraling around the black hole. Whatever the cause, it is a reminder that even our closest galactic neighbor has secrets left to unveil. Surrounding the entire galaxy is its halo, extending far beyond the visible disk. This halo is filled with not only dark matter but also tenuous hot gas, detected in X-rays. It is here that Andromeda interacts with the intergalactic medium, trading matter with its environment. Streams of stars reveal past mergers, dwarf galaxies that fell into Andromeda's grasp and were stretched apart by tidal forces. These streams are fossils of cannibalism, marking the galaxy's growth across cosmic time. Each one is a story of smaller systems sacrificed to feed the hunger of a larger whole. In all these structures, the nebulae, binaries, clusters, halos, and explosions, we glimpse the complexity of Andromeda. It is not a static postcard image but a living ecosystem, dynamic and evolving. To explore it is to learn not only about another galaxy, but about the forces that shape all galaxies, including our own. And as we uncover its details, we uncover reflections of ourselves. The same physics that governs its stars governs our sun. The same elements that fill its worlds fill our bodies. The same mysteries that cloak its core also cloak our cosmic future. Andromeda does not merely orbit silently across the void. It speaks, in light and shadow, in radiation and silence. All we need to do is listen. Across the deep night sky, Andromeda shines as a faint smudge to the unaided eye, a whisper of light among countless stars. To most of human history, it was nothing more than a cloud-like mystery, a celestial haze catalogued by ancient astronomers with no knowledge of its true scale. But today, we know that this faint glow is an entire galaxy, immense beyond imagination, and alive with cosmic history. To understand Andromeda is to understand a mirror of our own destiny, and to place our species in the grand narrative of the cosmos. The story of Andromeda is not just written in its present form but also in its past. Astronomers have traced streams of stars, long ribbons stretching across space, remnants of smaller galaxies torn apart by Andromeda's gravity. These tidal streams are scars of galactic cannibalism. Each one represents a collision that happened millions or even billions of years ago, when a dwarf galaxy wandered too close, was seized, and slowly dismantled. The stars of those once independent systems now orbit within Andromeda, indistinguishable from its native population. In this way, Andromeda has grown not through quiet isolation, but through a series of mergers, devouring its neighbors to become the giant we see today. Surrounding Andromeda is a family of smaller galaxies still bound to its gravity. M32, compact and bright, orbits close to Andromeda's heart. M110, more diffuse, drifts further out. Dozens of dwarf spheroidal galaxies accompany them, faint and elusive, barely visible against the black canvas of intergalactic space. Each of these satellites is a story waiting to be told, some dominated by dark matter, others stripped of gas, their star formation long extinguished. They circle Andromeda like attendants around a monarch, vulnerable to the tidal pull that may one day erase them. In their future lies assimilation, in Andromeda's, a continuing evolution sculpted by hunger. But not all of Andromeda's history is violent. Some of its structures reflect the quiet persistence of cosmic order. Its spiral arms, though shaped by density waves and star formation, maintain a symmetry that hints at underlying harmony. Its halo of globular clusters preserves memories of the early universe, when galaxies were forming from primordial gas clouds. In these ancient spheres lie the fingerprints of conditions mere hundreds of millions of years after the Big Bang. By studying them, we learn not just about Andromeda, but about the universe's youth, when matter first coalesced into islands of light. When we turn our instruments toward Andromeda, we do more than observe its light. We collect photons that have traveled for 2.5 million years, crossing the gulf of space to meet our telescopes. Each photon is a time capsule, a messenger from a distant past. When we gaze upon Andromeda tonight, we do not see it as it is, but as it was long before humanity even existed. The galaxy we will one day collide with is already different from the one we perceive, its stars shifted, its clusters moved, its supernovae exploded in silence while their light has not yet reached us. In this sense, astronomy is an act of time travel, and Andromeda is both a neighbor and an ancient ghost. The techniques we use to explore this galaxy are as remarkable as the galaxy itself. Optical telescopes capture its sweeping spirals. Radio telescopes map its hydrogen gas, tracing the cold fuel of star formation. Infrared observatories peer through dust to reveal the hidden birthplaces of stars. X-ray and gamma-ray instruments detect the violence of black holes and supernova remnants. Each wavelength is a different voice, together composing a symphony of cosmic understanding. To build a picture of Andromeda, astronomers weave these voices together, creating a portrait richer than any single instrument could achieve. Within Andromeda's countless stars, speculation naturally turns to the question of life. With hundreds of billions of suns, each potentially hosting planets, the odds of habitability are staggering. Some stars in Andromeda may cradle rocky worlds with atmospheres, oceans, and climates not unlike Earth's. Around others, exotic conditions might give rise to life forms unimaginable to us, creatures adapted to red dwarf suns, or to frozen exomoons orbiting gas giants. Though we cannot know for certain, Andromeda is not just a collection of stars, it is a potential cradle of countless unknown histories, civilizations that may rise and fall without our ever knowing. And yet, in contemplating them, we confront the profound scale of possibility. We are likely not alone in this galaxy-rich universe. If intelligent beings exist in Andromeda, their view of the cosmos is not so different from ours. Looking up at their night sky, they too would see the glow of a neighboring spiral galaxy, our Milky Way. For them, we are the faint smudge on the horizon, a mysterious island of light. Perhaps they too wonder if we harbor life, if our stars cradle worlds, if civilizations have risen on our rocky planet. Across the cosmic ocean, we are strangers looking at one another through the faint glow of distance, bound by physics, separated by time, connected by curiosity. The future of Andromeda intertwines with ours, but even beyond the merger, its destiny is part of a larger cosmic arc. Galaxies like Andromeda and the Milky Way are shaped not only by gravity and collisions but also by the expansion of the universe. As time stretches onward, other galaxies beyond our local group will drift away, carried by the accelerating expansion of space. In a distant future, Andromeda and the Milky Way may merge into one colossal elliptical galaxy, but the rest of the universe will fade beyond the horizon, unreachable, invisible. Our descendants may look out upon a dark sky, populated only by the legacy of this local union. To them, Andromeda will not be a neighbor but a part of their very being. In contemplating this, we find ourselves at a crossroads between science and philosophy. The study of Andromeda is not merely about another galaxy, it is about us. It is about recognizing that our sun is one of billions, that our Earth is one of countless worlds, and that our story is written on a canvas so vast that human history is but a flicker. Yet within that flicker lies awareness, the capacity to look outward and understand. We are the universe becoming conscious of itself, and Andromeda is the mirror in which we glimpse our reflection. The journey to Andromeda's center is not complete, for the galaxy holds endless secrets yet undiscovered. But already, our voyage has shown us that the cosmos is not a distant spectacle, it is our home. Each star, each cluster, each ribbon of light is part of a grander narrative that includes us. And though the distances are immeasurable, though the time spans dwarf our existence, we are not separate from them. We belong to the same story. And so, we drift onward, past satellites and streams, past clusters and cores, knowing that the Andromeda Galaxy is not just a destination but a reminder. A reminder that we are woven into the fabric of the cosmos, that our future is inseparably bound to other galaxies, and that even across millions of light years, the universe speaks a single language, one of beauty, motion, and eternity. Two galaxies approach one another in the silent vastness of intergalactic space. Their names, the Milky Way and Andromeda. To the human eye, they seem fixed, unmoving. But in reality, Andromeda is rushing toward us at nearly 250,000 miles per hour. No sound announces its approach, no visible distortion betrays the gravity drawing us together. And yet, in 4 billion years, the two will meet in a cosmic embrace unlike anything our species has ever witnessed. What happens when two spirals of such immensity collide? The first truth is counterintuitive. Despite the mind-bending scale, very few stars will actually strike one another. Stars are so tiny compared to the vast gulfs between them that even in a galactic collision, the chance of direct impact is vanishingly small. But the gravitational consequences will be profound. As the galaxies interpenetrate, their stars will be flung into new orbits. Some will be ejected entirely, cast adrift into intergalactic exile. Others will fall inward, joining the tumult near the central black holes. Still others will find themselves drawn into newly sculpted streams and arcs, reshaping the very outline of the galaxies. Computer simulations allow us to glimpse this future. In their models, two spiral galaxies merge not with a crash, but with a dance. They pass through one another, their disks distorted, their arms stretched into tidal tails tens of thousands of light-years long. Then, gravity pulls them back for another pass. Over hundreds of millions of years, they loop and interweave, until at last they settle into a single structure, no longer spirals, but an enormous elliptical galaxy, a new titan of starlight. This future galaxy, sometimes called Milkdromeda, will dominate the local group, a monument to cosmic evolution. In the chaos of the merger, gas clouds will collide and compress. These collisions will ignite furious bursts of star formation, lighting up the newborn galaxy with clusters of hot, young suns. It will be a renaissance of starlight, a last great wave of creation before the gas reservoirs are depleted. Supernovae will punctuate the sky with explosions, enriching the interstellar medium with heavy elements. For billions of years afterward, the new galaxy will shine with the legacy of this starburst, a reminder that even in destruction, the universe creates. At the heart of this merged system, two supermassive black holes will spiral toward one another. Each, millions of times the mass of the Sun, will warp space and time itself as they approach. Their dance will radiate gravitational waves, ripples in spacetime that race across the cosmos at light speed. When at last they merge, they will unleash more energy in that instant than all the stars of the galaxy combined. To us, if humanity still exists and has the means to observe, it will be a spectacle not of light but of spacetime itself, a shudder felt across the universe. For Earth, the story is more uncertain. By the time Andromeda and the Milky Way collide, our Sun will already be in its twilight years. It will have swelled into a red giant, perhaps engulfing Mercury and Venus, perhaps Earth itself. If our planet survives, its surface will be scorched, its oceans boiled away. Humanity, if it endures, will likely no longer call Earth home. But from whatever world or construct we inhabit, the spectacle in the night sky will be undeniable. Andromeda will grow larger with each passing epoch, until its spiral arms stretch across the heavens. When the two galaxies first pass through each other, the night will blaze with new stars. For our distant descendants, the sky will become a canvas of unparalleled grandeur, a reminder that the universe itself is not fixed but alive. Even after the merger, time will continue its relentless march. The brilliant new galaxy will slowly exhaust its gas, and star formation will dwindle. The fiery youth of Milkdromeda will give way to a quieter adulthood. Red and yellow stars will dominate, while the hot blue giants of the merger era will have long since burned out. Over trillions of years, the galaxy will fade, its stars dying one by one, until black holes, neutron stars, and white dwarfs carry the legacy of a luminous past. This is the long arc of galactic evolution, a burst of fire, followed by an eternity of embers. And yet, in contemplating this fate, we must remind ourselves of scale. To us, 4 billion years is an eternity. To the cosmos, it is merely a chapter. Galaxies have collided countless times before. Elliptical giants populate the universe as relics of such unions. What makes the story of Andromeda unique is not that it will merge with the Milky Way, but that we are here to witness, to predict, to imagine. For the first time in cosmic history, one of the participants in a galactic merger is aware of what is to come. What does this knowledge mean? It reminds us that permanence is an illusion. Even galaxies, grand as they are transient. They evolve, merge, and transform just as surely as stars are born and die. In their impermanence lies beauty, a universe not static, but dynamic, forever in motion. The inevitability of change is not a cause for despair but a testament to creativity, for the cosmos is always making something new. If humanity's future spans deep time, our descendants may one day live in Milkdromeda, calling it home as naturally as we call the Milky Way ours. They may map its star clusters, explore its remnants of ancient mergers, and tell myths of the age when two great spirals became one. To them, the idea of separate galaxies called Milky Way and Andromeda may be a story as old as legends are to us now. And if humanity does not survive, the merger will still unfold. The laws of physics do not wait for our species. Gravity will sculpt its masterpiece regardless of whether we are here to admire it. Yet the fact that we can know, can imagine, can tell this story, that is our triumph. For though we are small, though our lifespans are brief, we are part of the universe that understands itself. In Andromeda's approach, we find not a threat but a revelation, that our story is inseparably bound to the cosmos, and that even across billions of years, we belong to the same unfolding narrative. So the journey continues. From the faint glow in our sky to the grand collision in the future, Andromeda is more than a galaxy, it is a promise. A promise that the universe is not still, that our destiny lies not only on this world but among the stars, and that the greatest stories are not those we invent, but those written across the heavens themselves. To gaze at Andromeda is to confront the ultimate challenge of human curiosity, distance. 2.5 million light-years separate us from its stars. Even at the speed of our fastest spacecraft, it would take tens of billions of years to arrive, longer than the age of the universe itself. And yet, humanity has never allowed impossibility to silence its questions. Instead, we turn impossibility into inspiration, seeking new ways to cross barriers that once seemed eternal. Our first tools are not ships but telescopes. Already, we have built observatories that can peer across cosmic time. The Hubble Space Telescope revealed Andromeda's spiral arms in astonishing detail, counting individual stars within another galaxy for the first time. The James Webb Space Telescope has gone further, probing its dusty nurseries, uncovering the birth of stars hidden from optical eyes. In the decades ahead, even more powerful instruments are planned, telescopes with mirrors the size of city blocks, arrays spread across continents, and perhaps someday, observatories orbiting the Sun at distances vast enough to use gravity itself as a lens. Gravitational lensing may be our greatest key. When a massive object, such as the Sun, bends light, it acts as a natural telescope. If we could send a spacecraft hundreds of billions of miles away, positioning it so that the Sun's gravity focuses Andromeda's light, we could achieve magnification impossible by any other means. Theoretical studies suggest we could resolve not just stars but planets within Andromeda, perhaps even detecting atmospheric signatures. In this way, the universe itself becomes our tool, bending its laws to feed our hunger for knowledge. But telescopes alone will not satisfy forever. Humanity has always sought not just to observe, but to go. To dream of intergalactic travel is to dream beyond the limits of our physics. At present, nothing allows us to exceed the speed of light, and so journeys to Andromeda remain fantasy. Yet within physics lie ideas as audacious as myth. Wormholes, shortcuts through spacetime. Warp drives, manipulations of space itself. Exotic concepts that blur the line between science and imagination. Most may never leave the realm of theory. Yet they remind us that the universe is vast, and our understanding incomplete. What seems impossible today may, in some far future, be as natural as sailing once was to those who first looked across an ocean. Even if we never step foot in Andromeda, our probes might. Imagine machines built not for decades but for millennia, carrying artificial intelligence that evolves as it travels, adapting to the deep void. Tiny light sail craft, pushed by beams of energy, could one day drift between galaxies, crossing the gulf not in human timescales, but in cosmic ones. They would arrive long after our civilizations have changed, but their presence would mark the persistence of curiosity, a signature of humanity written into the stars. In the meantime, Andromeda teaches us patience. We study it not by going there, but by decoding its light. Each photon tells a story, of the star it left, of the dust it passed, of the gravity that bent its path. Our detectors turn these photons into data, and data into meaning. In this way, we practice a form of remote exploration unlike anything else. We may never touch Andromeda with our hands, but we can touch it with our minds. Science is not our only guide. Philosophy too finds its reflection in Andromeda's glow. For here we confront questions of scale, of significance, of meaning. What is humanity to a galaxy? A flicker. A breath. Yet in that breath lies awareness, the power to comprehend billions of years and trillions of stars. The fact that we can imagine Andromeda's core, its black hole, its clusters, its future collision with us, that fact alone elevates our brief existence into something cosmic. Andromeda is also a mirror for our hopes. When we wonder about life there, we are wondering about ourselves. When we imagine civilizations looking back at us, we are acknowledging our solitude and yearning for connection. The galaxy is not just a collection of stars, it is a screen onto which we project our deepest questions. Are we unique? Are we temporary? Do we matter in a universe so immense? Andromeda does not answer directly. But its presence, steady and luminous, whispers that our questions are themselves part of the story of the cosmos. Future generations may build instruments that make today's telescopes seem primitive. They may see Andromeda not as a distant smudge, but as a place, with resolved stars, mapped planets, catalogued moons. They may even send their voices across intergalactic space, radio waves intended not for us, but for them, for whatever beings may dwell beneath its suns. And though the odds of reply are slim, the act of sending would itself be an expression of who we are, explorers not of land or sea, but of possibility. As we stand at the edge of our technological dawn, the thought of Andromeda expands our vision. It reminds us that our planet is small, our solar system modest, our galaxy not unique. To be human is to long for more, to push boundaries, to imagine futures, to build bridges across the unknown. Andromeda is not just a neighbor, it is a symbol. A reminder that beyond our immediate struggles lies an infinite canvas, waiting for the brush of curiosity. Perhaps one day, our descendants will tell stories not only of Andromeda as seen from Earth, but of Earth as seen from Andromeda. They will speak of a time when we were confined to one planet, when galaxies were mysteries painted across the night. They will marvel that we, fragile and finite, once looked up and dared to dream of reaching the stars. Until then, Andromeda waits. Patient, silent, radiant. A destination unreachable, yet always present. And in that paradox lies its power. For the journey to Andromeda is not measured in miles, but in imagination. And imagination is the one force in the universe that allows us to transcend time, space, and even the limits of ourselves. The story of Andromeda is not confined to its present brilliance, nor even to its merger with the Milky Way. To truly understand this galaxy, we must extend our gaze far beyond the horizons of human timescales. We must ask, what becomes of Andromeda not just in billions of years, but in trillions? What role does it play in the final chapters of cosmic history? When Milkdromeda, the union of our two great spirals, finally settles into a vast elliptical form, its story will be far from over. For tens of billions of years, stars will continue to burn, though slowly, their fuel dwindling. The hot blue giants of the merger era will be long gone, leaving behind neutron stars and black holes. What remains will be smaller suns, red dwarfs, quiet and enduring, flickering across time spans that dwarf all of human history. Some of these humble stars may live for trillions of years, far outlasting the current age of the universe. In their glow, if planets still circle, there may remain a chance for life, however alien and slow-paced it might be. But star formation cannot last forever. Eventually, the cold reservoirs of hydrogen will run dry. Gas will be locked into long-lived stars and stellar remnants, with no fresh clouds to ignite. Milkdromeda will enter its middle age, then its twilight. For a time, it will shine as a grand elliptical giant, populated by billions of red suns. Yet gradually, over unimaginable spans, one by one, those stars will exhaust their fuel. The galaxy will dim. In its place will remain a graveyard of stellar corpses, white dwarfs cooling into black dwarfs, neutron stars spinning in silence, black holes lurking in the dark. These objects will persist, but without new light, Andromeda will fade into shadow. Its once proud arms and blazing core will be gone, replaced by a diffuse swarm of embers drifting in the void. Beyond the boundaries of this new galaxy, the wider universe will have changed as well. Today, galaxies drift apart, carried by the expansion of space. But as time passes, that expansion will accelerate, driven by the mysterious force we call dark energy. Galaxies outside our local group will recede faster and faster, until eventually, they vanish beyond our cosmic horizon. The light they emit will never reach us. To the far future astronomers of Andromeda, the universe will appear empty. Only their own galaxy will remain visible, a lonely island adrift in eternal darkness. This cosmic isolation is inevitable. Already, the seeds are sown. In 100 billion years, no other galaxies will be seen. The night sky will no longer tell the story of a universe filled with countless stars, but only of one fading empire of light, Andromeda. And as the stars of that galaxy die, the universe will slip into its long decline. Physicists call it the heat death, the point at which all energy is spread so thinly that no structure remains. Galaxies dissolve into remnants. Black holes dominate for a time, swallowing matter and merging with one another. But even black holes are not eternal. Over unimaginable spans, they too evaporate, releasing their energy into space as Hawking radiation. In the end, all that remains is darkness, a thin mist of particles spread across infinite cold. Where, then, does Andromeda's story end? Perhaps it ends not with a bang but with silence. Perhaps the last remnants of Andromeda drift into the void, its final stars extinguished, its final black holes faded. In this vision, the galaxy we now admire as a beacon of light becomes a whisper in the memory of the cosmos. And yet, there is another possibility. For just as we cannot fully know the depths of dark matter, we cannot yet fully grasp the nature of dark energy. Perhaps the universe has surprises yet to reveal. Perhaps the story of Andromeda, of Andromeda, of the local group, is not one of fading, but of transformation. Some cosmologists speculate about cyclic universes, in which expansion halts and reverses, galaxies collapse together, and a new Big Bang ignites. If so, then the atoms forged in Andromeda's stars may one day form part of a future cosmos, reborn from the ashes of the old. Even if the universe does end in silence, the act of contemplating this distant fate changes us. For here we touch the boundary between science and philosophy. To know that Andromeda will one day fade is to accept impermanence not just of stars, but of everything. To know that galaxies themselves are temporary is to see our own mortality reflected on the grandest scale. Yet instead of despair, we may find awe. For impermanence is also the essence of creation. Without death, there is no life. Without change, no beauty. Without endings, no beginnings. Andromeda, like all galaxies, is a teacher. It shows us that greatness is not eternal, but transient. That brilliance burns, then fades, but in fading gives birth to new forms. It shows us that even across unimaginable distances and times, there is coherence, order, story. And in that story, we are included. For when we look at Andromeda tonight, we are not merely seeing a galaxy. We are seeing our own future, our own fate, our own reflection stretched across the stars. And when we imagine its final embers cooling into darkness, we are not imagining loss, but transformation, the universe turning the page to its next chapter, whatever it may be. And so, the journey to the center of Andromeda is not merely an exploration of space. It is an exploration of time, of destiny, of meaning. A galaxy is more than stars, it is a mirror in which we glimpse eternity. As our vision fades, we carry with us the knowledge that the Andromeda Galaxy will not last forever, but its story will never be lost, for we are here to tell it. Long before we knew the true scale of the universe, before the word galaxy meant more than the hazy band of the Milky Way above our heads, human eyes had already discovered Andromeda. To ancient skywatchers, it appeared as nothing more than a faint smudge, a cloud-like glow in the dark of night. The Persians called it the little cloud. The Greeks placed it in their mythology, linking it to the tale of Princess Andromeda chained to the rocks by the sea. To them, it was not a galaxy, not a distant universe, but a starry ornament in their tapestry of gods and legends. Through centuries, Andromeda remained just that, a mystery on the edge of sight. Without telescopes, it could not be resolved. And so it lingered, an enigma, a ghost of light that refused to reveal itself. Medieval astronomers catalogued it, noted its presence, but did not grasp its true nature. Even in the Renaissance, when the first lenses brought the moon and planets into sharp relief, Andromeda remained elusive, too diffuse to be fully understood. It was in the 17th century that Galileo's invention of the telescope began to shift perspective. Observers peered at the Andromeda Nebula, as it was then called, and described its fuzzy glow in greater detail. Yet still, it was thought to be a cloud within our own galaxy, a strange condensation of stars or gas in the Milky Way. For centuries, astronomers debated, was it a local object, part of our own star system, or something greater, something beyond? The debate reached its peak in the early 20th century, in what became known as the Great Debate. Two astronomers, Harlow Shapley and Heber Curtis, stood at opposite ends of the question. Shapley believed the Milky Way was the entire universe, and that Andromeda was but a nearby cloud within it. Curtis argued that Andromeda and similar nebulae were, in fact, entire galaxies, island universes, far beyond our own. The question divided astronomy, for it was no small matter. To answer it was to answer the very size of the cosmos. The turning point came with one man, Edwin Hubble. Using the 100-inch Hooker telescope on Mount Wilson in the 1920s, Hubble observed Cepheid variable stars within Andromeda. These stars, whose brightness pulses with predictable rhythms, served as cosmic yardsticks. By measuring their period and brightness, Hubble calculated the distance. His conclusion was staggering: Andromeda lay not within the Milky Way, but far beyond, at more than 2 million light-years away. The smudge in the sky was not a cloud, but an entire galaxy. Overnight, the universe expanded from one galaxy to many. Humanity's vision of the cosmos had exploded. The revelation did more than redraw maps, it reshaped philosophy. We were no longer the sole island of stars in an otherwise empty sea. The universe was teeming with galaxies, each vast, each filled with billions of suns. Andromeda was not an outlier, it was a neighbor, one of countless others. The Copernican revolution, which once displaced Earth from the center of the solar system, now displaced the Milky Way from the center of the universe. Andromeda was the herald of this new perspective. Since then, technology has sharpened our gaze. Photographic plates captured its structure. Radio astronomy traced its hydrogen clouds, mapping the flows of gas. Infrared telescopes revealed the hidden nurseries of stars. X-ray observatories uncovered the violent heart of its binaries and black holes. Each wavelength peeled back another layer of mystery, showing that Andromeda was not static, but alive with birth, death, and transformation. The Hubble Space Telescope, orbiting above Earth's atmosphere, resolved individual stars within Andromeda as though it were part of our own backyard. It photographed globular clusters, supernova remnants, and even the faint glow of planetary nebulae. For the first time, humanity could study another galaxy star by star, bridging the gulf of millions of light-years with the lens of technology. And now, with the James Webb Space Telescope, the story continues. Webb's infrared eyes pierce through dust, revealing the youngest stars, the warm glow of forming planets, the structure of nebulae never before seen. Andromeda, once a faint smudge, has become a laboratory, a place where we test our theories of star formation, galactic dynamics, and cosmic evolution. What was once myth has become science, and what was once unreachable is now a subject of data. But the story of Andromeda is not only the story of astronomy, it is the story of humanity. Each advance in observing it has paralleled advances in our sense of self. Ancient myths made it a symbol of human drama. Early telescopes made it a puzzle to be solved. The Great Debate made it a battlefield of ideas. Hubble's discovery made it a revelation. And today, it remains a constant reminder that our knowledge is never complete, that each answer opens new questions. What will the future bring? Perhaps telescopes spread across the moon, forming an array so vast it can resolve planets in Andromeda directly. Perhaps spacecraft stationed at the gravitational focus of the Sun, millions of miles away, will turn the entire solar system into a telescope, magnifying distant worlds. Perhaps artificial intelligence will analyze light with precision beyond human capability, extracting signals of atmospheres, oceans, and even biosignatures on exoplanets orbiting Andromeda's stars. And what of civilizations beyond? If intelligent life exists in Andromeda, perhaps they too have looked outward and discovered us. Perhaps they too have had their own Great Debate, their own Edwin Hubble, their own moment of revelation. Perhaps they see the Milky Way as a faint smudge and wonder if it is an island universe, if it harbors stars, if it harbors life. In this reflection, we find a symmetry, two galaxies separated by millions of light years, yet linked by the same impulse to look upward, to question, to seek. The journey of Andromeda through human history is a journey of perspective. From a myth to a nebula, from a nebula to a galaxy, from a galaxy to a neighbor, from a neighbor to a destiny. Each stage has deepened our sense of scale and humbled our sense of place. And in that humility, we have found wonder. Andromeda teaches us not only about the universe, but about ourselves. It shows us that knowledge is a process, that truth unfolds step by step, and that every generation sees further than the last. It reminds us that curiosity is the most powerful force we possess, the force that turns clouds into galaxies, myths into science, dreams into understanding. When we gaze at Andromeda tonight, we are not only seeing a galaxy 2.5 million light-years away. We are seeing the journey of our own minds, stretched across millennia, from the eyes of ancient skywatchers to the mirrors of space telescopes. And in that journey lies the essence of what it means to be human, to see, to wonder, to know. Andromeda is our closest galactic neighbor, yet it is not simply a twin of the Milky Way. To compare it with other galaxies across the universe is to see its true character emerge. In the great gallery of galaxies, each is a variation on a theme, shaped by the same laws but sculpted by different histories. Andromeda is both ordinary and extraordinary, a cosmic archetype and a singular entity. Spiral galaxies like Andromeda are among the most striking structures in the cosmos. They possess graceful arms of starlight, disks of dust and gas, and central bulges where stars cluster in dense brilliance. Yet even within this family, Andromeda stands out. It is larger than most spirals, stretching over 220,000 light-years from edge to edge, nearly double the diameter of our own Milky Way. Its mass too is immense, containing hundreds of billions of stars, perhaps a trillion in total. Where many galaxies of its type fade into obscurity, Andromeda radiates as one of the giants of the local universe. Contrast it with the Triangulum Galaxy, M33, another spiral in our local group. Triangulum is delicate, its arms less pronounced, its size a fraction of Andromeda's. Though beautiful, it is a smaller sibling, a reminder that galaxies come in many scales. Compare Andromeda to the grand design spirals further afield, such as M81 in Ursa Major or NGC 1300 with its sweeping barred arms, and we see similarities, yet Andromeda retains a distinct asymmetry. Its spiral is slightly distorted, a hint of past encounters and ongoing mergers. Unlike the perfect symmetry of textbook spirals, Andromeda wears the marks of history on its disk. Then there are the elliptical galaxies, the end state of many cosmic collisions. Giant ellipticals like Messier 87 tower over Andromeda in sheer mass, containing trillions of stars in featureless swarms. They lack the delicate arms, the glowing gas, the ongoing star formation that makes spirals vivid. Andromeda, by contrast, is still alive with activity. Its nebulae burn with new stars, its arms blaze with young clusters. To see Andromeda today is to see a galaxy in its prime, before the merger with the Milky Way transforms it into an elliptical titan of its own. When astronomers study Andromeda, they do so not only to understand this galaxy but to understand galaxies as a whole. It is close enough to resolve into individual stars, something impossible in more distant systems. This makes it a laboratory, a place where theories of galactic dynamics, star formation, and chemical enrichment can be tested in detail. Observing Andromeda's halo, for example, reveals the relics of dwarf galaxies it has consumed, teaching us how large galaxies grow. Mapping its rotation curve exposes the invisible presence of dark matter, showing that its gravitational skeleton extends far beyond its luminous body. Comparisons reveal not only differences but patterns. Spiral galaxies like Andromeda and the Milky Way appear to follow a cosmic rhythm. The larger they are, the faster their stars orbit. Yet the rotation does not diminish with distance as Newtonian gravity would suggest. Instead, stars in Andromeda's outermost regions orbit almost as quickly as those nearer the center. This is the signature of dark matter, and it is through galaxies like Andromeda that this cosmic mystery was first uncovered. The galaxy is not just an island of light, it is evidence for the unseen majority of the universe. Looking further, we find galaxies in every stage of life. Some, like the irregular Magellanic Clouds orbiting our Milky Way, are small and chaotic, shaped by tidal forces. Others, like starburst galaxies, blaze with furious creation, their cores erupting with new stars at extraordinary rates. Still others are quiescent, exhausted of gas, fading into senescence. Andromeda stands between these extremes, active, yet not explosive, massive, yet not the largest. It is a balance point, a galaxy in maturity, offering us a stable vantage to study what galaxies are when they thrive. But what truly makes Andromeda unique is its accessibility. While other galaxies may be brighter or more massive, none beyond the Milky Way is as close, as detailed, as resolvable. It is the only spiral galaxy we can study almost star by star, a bridge between our home and the wider cosmos. Through Andromeda, we calibrate our tools, refine our measurements, and extend our reach outward. It is the nearest example of the vast structures that populate the universe, a Rosetta Stone for galactic astronomy. Andromeda also reminds us that no two galaxies share the same path. Its asymmetries hint at collisions past, its streams of stars tell of devoured companions. Its central black hole, though massive, is smaller than that of many ellipticals. Its disk is warped, tilted by interactions with satellites. Every feature tells a story of unique events, mergers, starbursts, quiet ages, violent outbursts. In studying Andromeda, we see that galaxies are not static, but autobiographies written across billions of years. Andromeda's place in cosmology is profound. It was the first external galaxy confirmed beyond the Milky Way, the herald of the island universe concept. It was also the first to reveal the presence of Cepheid variables beyond our galaxy, which led to measuring the scale of the cosmos. Its rotation curve became key evidence for dark matter. Its future collision with US gives insight into galactic evolution. In every way, Andromeda has been central not only to astronomy but to our very definition of the universe. Compare it now with the most distant galaxies we have ever observed. With telescopes like James Webb, we see galaxies as they were only a few 100 million years after the Big Bang, tiny, chaotic, clumped. From those embryonic forms, the grand spirals and ellipticals of today evolved. Andromeda is one of the results of that process, a matured descendant of those first flickers of light. In it, we see both the past and the future, the culmination of cosmic growth, and a preview of the fate awaiting other galaxies. So when we place Andromeda in context, we see it as both ordinary and extraordinary. Ordinary, in that it is one of billions of galaxies governed by the same laws, shaped by the same physics. Extraordinary, in that it is close enough to reveal its secrets in exquisite detail, shaping our understanding of all the rest. It is a microcosm of the universe itself, complex, dynamic, evolving, and forever beyond the reach of final certainty. And so, Andromeda does not stand alone in the heavens. It stands among countless others, a single note in a cosmic symphony. Yet for us, it is the most important note, the one we can hear most clearly, the one that teaches us the music of the universe. When we gaze at it, we do not just see another galaxy. We see the bridge between our world and the infinite, the pattern that connects the many to the one to the many. And in that connection, we find our place, small, fleeting, yet bound to the whole. Galaxies are not built of uniform light. They are built of stars, billions upon billions of individuals, each with its own history, its own chemistry, its own fate. To journey through Andromeda is to journey through a census of stellar lives, a library whose shelves stretch across hundreds of thousands of light-years. Within this library, every star is a page, and together, they tell the biography of a galaxy. Astronomers divide these stars into populations, a shorthand for age, composition, and ancestry. In Andromeda's spiral arms shine the young ones, rich in heavy elements, luminous and hot. These are population 1 stars, children of the most recent cycles of creation. They are born in nebulae still rich with metals forged by generations of earlier suns, oxygen, carbon, silicon, iron, all the building blocks of planets and life. To see Andromeda's arms aglow is to witness a youth in bloom, galaxies painting themselves with brilliance that will last only a cosmic instant. Moving inward, the story changes. The bulge and halo are home to population 2 stars, older and poorer in heavy elements. These suns formed when the universe was younger, when only a few generations of supernovae had seeded the cosmos with metals. They burn cooler, steadier, and longer. Many of them are older than Earth, older than the solar system, older than almost every story humanity has told. Around them may orbit planets built not of rich chemistry but of simpler matter, worlds without the abundance of carbon or oxygen that defines our biology. Yet still, they endure, living testaments to a galaxy's ancient past. Among these elders are the true ancients, population 3 stars, or rather, their echoes. These first stars of the universe no longer shine, for they lived briefly and died violently. But their ashes seeded the gas that later formed Andromeda's oldest stars. In the chemistry of Andromeda's halo, astronomers find traces of this early epoch, stars with barely any heavy elements at all, fossils of a time when the cosmos knew only hydrogen and helium. To study them is to peer back almost to the beginning, to glimpse the raw ingredients from which everything was made. Yet not all stars follow simple lives. Some become exotica, objects as strange as they are rare. In Andromeda, astronomers detect pulsars, neutron stars that spin with incredible speed, flashing beams of radiation like cosmic lighthouses. Some rotate hundreds of times per second, their precision rivaling the most accurate clocks humanity has ever built. Each one is the remnant of a massive star's death, its core collapsed to unimaginable density, its crust vibrating with magnetic storms. Across millions of light-years, their signals reach us, faint but unmistakable, a reminder of stellar violence and endurance. There are white dwarfs as well, cores of dead stars, slowly cooling embers that will one day fade into blackness. Some white dwarfs in Andromeda exist in pairs, their mutual gravity drawing them closer until one siphons matter from the other. When the mass grows too great, they ignite in thermonuclear fury, creating a type Ia supernova, a brilliant beacon visible across galaxies. These explosions are so reliable in their brightness that astronomers use them as standard candles, measuring cosmic distances. In this way, Andromeda's white dwarfs have helped us map the very expansion of the universe. Other exotic objects lurk in the disk, X-ray binaries, where black holes or neutron stars devour matter from a stellar companion. As the gas spirals inward, it heats to millions of degrees, emitting radiation that reveals the otherwise invisible. These systems are laboratories of physics under extremes, places where gravity, magnetism, and matter collide in ways no earthly experiment can reproduce. And then there are the rare jewels, planetary nebulae, shells of gas cast off by dying stars. In Andromeda, they appear as tiny orbs of light, each one a farewell gesture of a sun-like star nearing its end. Their colors reveal their chemistry, green from oxygen, red from nitrogen, blue from helium. To see them scattered across the galaxy is to see a constellation of last breaths, a reminder that even death in the cosmos is luminous. Beyond the stars themselves, background objects visible through Andromeda add depth to the picture. Quasars, distant galaxies powered by actively feeding black holes, shine from behind its disk. Their light passes through Andromeda's gas and dust, allowing astronomers to study the galaxy's invisible medium as a silhouette against even greater distances. By analyzing these fingerprints, scientists can trace the distribution of elements, the structure of interstellar clouds, and the faint halo of gas that envelopes the galaxy. Each type of star in Andromeda tells part of its story. The young, metal-rich stars reveal ongoing creation. The older, metal-poor stars testify to ancient origins. The exotic remnants show the violence of stellar deaths. The background quasars add a cosmic context, turning Andromeda into a lens through which we glimpse the wider universe. Together, they form a timeline stretching from the earliest epochs to the far future, all embodied in one galaxy. For astronomers, this diversity makes Andromeda not just an object of beauty, but of measurement. Cepheid variables there helped us learn distances. Supernovae there helped us trace cosmic expansion. Pulsars there refine our understanding of gravity. In every corner of the galaxy, data whispers truths about the laws of nature. Andromeda is not a passive neighbor, it is a collaborator in the great experiment of understanding existence. For us, standing on Earth beneath its faint glow, all of this richness is hidden. To the naked eye, it remains a blur, a soft patch of light easily mistaken for a cloud. But behind that blur lies a population of stars more numerous than we can comprehend, each with its own destiny. To realize this is to realize the scale of creation, that galaxies are not monoliths but communities, vast and diverse, each individual star as real as our own sun. In contemplating Andromeda's stellar populations, we find ourselves drawn into a paradox. We are insignificant compared to its scale, yet intimately connected. The carbon in our cells was forged in stars much like those scattered across its disk. The physics that governs their lives governs ours. To understand them is, in a way, to understand ourselves. And so, the journey continues, not through nebulae or black holes this time, but through the quiet variety of stars themselves. Each population a chapter, each remnant a footnote, each supernova a punctuation mark in a story that stretches across eternity. When we look at Andromeda tonight, we see not a single object, but a galaxy alive with billions of lives. And in their glow, faint though it may be across the gulf of space, we see the reflection of our own. Galaxies are rarely alone. Though separated by millions of light-years, they gather in families bound by gravity, forming clusters, groups, and superclusters that stretch like cosmic webs across the universe. Andromeda is no exception. It belongs to a modest family of galaxies called the Local Group, a gravitational neighborhood that includes our Milky Way, the smaller Triangulum Galaxy, and dozens of dwarf companions. To understand Andromeda fully, we must see it not as an isolated island, but as a central actor in this galactic ensemble. The Local Group spans about 10 million light-years across, yet its mass is concentrated in two giants, the Milky Way and Andromeda. Together, they dominate the gravitational field of this region, pulling smaller galaxies into their orbits like monarchs surrounded by courtiers. Around them, faint spheroidal dwarfs drift, many so diffuse that they were only discovered in recent decades with deep sky surveys. These tiny galaxies are laboratories of dark matter, their visible stars sparse but their masses immense, held together by invisible halos. Each one circles like a moth around the flame of a much larger host, vulnerable to eventual absorption. Among Andromeda's companions, the brightest is Messier 32, a compact elliptical dwarf. Unlike sprawling galaxies with delicate arms, M32 is small, dense, and tightly packed. Its stars are old, its gas long gone, its star formation extinguished. Some astronomers believe it was once a larger galaxy, stripped of its outer stars and gas by Andromeda's gravity, leaving behind only its naked core. To orbit Andromeda is to risk being consumed by it, and M32 bears the scars of that fate. M110, another companion, is larger but fainter. It too is elliptical, with a smoother structure, its star formation slowed but not entirely dead. Streams of stars connect it to Andromeda, faint bridges across the void that betray the tug of tidal forces. To the eye, they are invisible. To sensitive instruments, they appear as whispers of ancient interactions, galaxies exchanging stars as though scattering breadcrumbs across the night. The most intriguing member of this galactic family, however, is the Triangulum Galaxy, M33. Though far smaller than Andromeda or the Milky Way, M33 is a spiral in its own right, with defined arms and an active population of star-forming regions. Astronomers debate its relationship to Andromeda. Is it a satellite, bound by Andromeda's pull, or is it an independent member of the local group? Observations suggest that M33 may one day merge with Andromeda, either before or during the grand collision with the Milky Way. If so, then the local group is destined not only for a binary union of two giants, but for a triple dance, three spirals woven together into a single galactic future. Between these galaxies, bridges of stars and gas are already forming. Sensitive surveys reveal stellar streams stretching from Andromeda's halo, remnants of smaller galaxies long since devoured. Some streams appear to point toward M33, as though stars have been tugged between the two. These faint structures are fossils of gravitational interaction, written across the darkness like scars of encounters millions of years past. Such interactions are not violent crashes but slow tides. Over millions of years, gravity pulls at the outskirts of galaxies, distorting their shapes, siphoning stars into bridges and arcs. To a human lifespan, they are invisible. To the universe, they are inevitable. Andromeda's warped disk is evidence of such encounters, its spiral not perfectly flat, but bent, tilted by the hands of gravity that reached out from companions long ago. The local group itself is not a closed system. Beyond its borders lie larger clusters, such as the Virgo cluster, a vast assembly of thousands of galaxies. The local group is only a small thread in the great cosmic web, drawn inexorably toward Virgo by the pull of gravity on scales beyond imagination. Andromeda, the Milky Way, Triangulum, and their satellites are not merely orbiting each other, they are also part of a larger flow, drifting toward structures far greater than themselves. To study Andromeda's place in this environment is to glimpse the choreography of cosmic evolution. Galaxies grow not only by forming stars, but by merging, cannibalizing, and interacting. Andromeda's present size is the result of countless such interactions, and its future size will be the result of many more. The faint star streams around it are evidence of meals consumed, each dwarf galaxy torn apart, its identity dissolved. The companions that remain are already fated to similar ends. In the fullness of time, Andromeda will not orbit among satellites. It will absorb them, becoming the remnant of everything once bound to it. And yet, for now, the local group is a balance of forces. Two titans, Andromeda and the Milky Way, move toward each other, while M33 hovers nearby, its fate uncertain. Dozens of dwarfs orbit silently, awaiting the gravitational tides that will erase them. Streams of stars lace the darkness, too faint for human eyes but vivid in data. And through it all, Andromeda shines as the anchor of the group, its presence shaping the destiny of everything around it. From Earth, this complexity is reduced to a faint smudge in the sky. But behind that smudge lies an empire of gravity, a web of galaxies bound together in slow-motion drama. To look at Andromeda is not only to see a single galaxy, but to see the local group itself, the family to which we belong. It is to realize that our Milky Way is not solitary, but part of a dynamic community, one whose members will one day merge into a single galactic future. The story of Andromeda is not just the story of stars and nebulae within it. It is the story of neighbors, of interactions, of relationships. Galaxies, like people, exist not in isolation but in networks, shaped as much by their companions as by themselves. And in that truth lies a reflection of our own existence, that even across the vastest scales, connection defines us. If Andromeda appears to us as a static glow across the night sky, it is only because human eyes are slow. In truth, every part of the galaxy is in motion. Stars orbit, gas clouds drift, spiral arms shift, and the entire system breathes with the rhythm of gravity. To understand Andromeda is to understand this dance of motion, a ballet performed not in seconds but in millions of years. The first clue comes from its rotation. When astronomers measure the speed of stars within Andromeda, they find something astonishing. Near the core, stars orbit quickly, as expected, pulled by the gravity of billions of neighbors. But as we move outward, the speed does not fall off as Newton's laws would predict. Even at distances far from the bright disk, stars continue to orbit at nearly the same velocity, hundreds of kilometers per second. This anomaly cannot be explained by visible matter alone. The luminous stars and gas account for only a fraction of the required mass. The rest must be hidden, invisible. Thus, Andromeda became one of the first galaxies to reveal the mystery of dark matter. Dark matter is not light, not gas, not dust. It does not shine, reflect, or absorb. It interacts only through gravity, yet its presence is undeniable. Around Andromeda, an enormous halo of dark matter envelopes the galaxy, extending far beyond its visible disk. This halo contains far more mass than all its stars combined, shaping every orbit, controlling every motion. Without it, the galaxy would fly apart. With it, Andromeda holds together, a luminous island within an invisible sea. The rotation curve of Andromeda is not only evidence of dark matter, but also a map of its distribution. By measuring how speed changes with radius, astronomers reconstruct the density of this hidden halo. It is not concentrated at the center like stars, but spread diffusely, reaching far into intergalactic space. In this way, Andromeda teaches us not only about itself but about the fundamental structure of the universe. For every galaxy studied shows the same pattern, visible matter alone cannot account for the motions we see. Yet the dynamics of Andromeda are more than rotation. Within its disk, spiral density waves organize the flow of stars and gas. These are not material arms that rotate as solid structures, but patterns, waves of compression moving through the disk. As stars and gas enter the wave, they slow, bunching together, triggering bursts of star formation. As they leave, they spread out again, making way for new arrivals. It is like traffic on a cosmic highway, where the jam itself moves while the cars pass through. This is why Andromeda's arms remain distinct over billions of years, even as individual stars orbit at different speeds. Gas plays its own role in the galactic dance. Vast streams of hydrogen trace the skeleton of Andromeda, feeding star formation and revealing past interactions. Radio observations show that this gas is not evenly distributed, but warped and twisted. The disk itself is bent, likely by gravitational encounters with companion galaxies. These warps ripple outward, bending the orbits of stars and gas, shaping the galaxy into a form less perfect than the illustrations in textbooks. Real galaxies are messy, alive with the memory of every tug and twist they have endured. Within the central regions, motion is more chaotic. Stars orbit not in flat planes but in complex ellipses, influenced by the gravitational pull of the central black hole. Some whip around at thousands of kilometers per second, tracing paths that bring them perilously close before flinging them outward again. Occasionally, one star is ejected entirely, cast into intergalactic space by a close encounter with the black hole's gravity. These hypervelocity stars travel forever, lonely wanderers carrying the signature of Andromeda's core. Clusters of stars also tell the story of motion. Globular clusters orbit in the halo, tracing paths that reveal the distribution of dark matter far beyond the disk. Some of these clusters do not belong to Andromeda at all, but are remnants of smaller galaxies torn apart and absorbed. Their orbits betray their origins, looping along the faint stellar streams that crisscross the halo. By mapping them, astronomers reconstruct Andromeda's history of cannibalism, its growth through the ingestion of smaller systems. The dynamics extend beyond stars and gas to cosmic rays and magnetic fields. Charged particles, accelerated by supernovae, spiral along invisible filaments of magnetism that thread the galaxy. These fields, though weak, shape the flow of matter, guiding the collapse of clouds and influencing the birth of stars. They too are part of the choreography, unseen but essential, like the conductor's hand directing a symphony we cannot hear. To grasp the scale of Andromeda's motion, we must also remember its trajectory through space itself. The entire galaxy hurtles toward the Milky Way at hundreds of kilometers per second. Though imperceptible in a human lifetime, measurements across decades show its approach, confirmed by Doppler shifts in its light. It is not static, not fixed against the backdrop of the universe, but moving inexorably toward a future collision. The internal motions of stars and gas are but one layer of movement within this grander orbit. The study of dynamics transforms Andromeda from an image into a story. A still photograph reveals beauty, but motion reveals life. Each orbit, each warp, each stream is a record of forces at play. Stars circle for billions of years, their paths shaped by both the visible and the unseen. Gas flows like rivers, compressed and released in endless cycles. Dark matter provides the scaffolding, invisible but dominant, holding the entire structure together. And in these motions, we find not chaos but order. The laws of physics, unchanging across time and distance, govern every orbit in Andromeda. Newton's gravity, Einstein's relativity, the rules of thermodynamics and electromagnetism, all play their part in the ballet of stars. To watch Andromeda move, even through data alone, is to watch the universe express itself through pattern and law. For us, the significance is profound. By decoding these motions, we not only learn the structure of Andromeda but also test the foundations of physics itself. The galaxy becomes a laboratory, an experiment running for billions of years, observable from across the void. Its stars are not only suns but test particles in a cosmic equation. Its gas is not only fuel for stars but tracer of invisible structures. Its dynamics are not only motion but revelation. When we look at Andromeda tonight, we see not a still smudge of light, but a galaxy alive with motion. Every photon that reaches us carries within it the signature of velocity, the fingerprint of movement. To see it is to witness not a painting, but a dance, a choreography written by gravity, performed by stars, and illuminated for our eyes across 2.5 million years of travel. And in that dance, we glimpse the deeper truth: the universe is not static, but forever in motion. Andromeda is not merely there, it is becoming, evolving, changing, moving. And in its motion, we see not only its story, but the story of the cosmos itself. To appreciate Andromeda fully, we must think in scales. Galaxies are not single entities, but hierarchies of structures nested one within another. From the intimacy of planets orbiting suns to the enormity of superclusters spanning hundreds of millions of light-years, Andromeda is part of a grand continuum. Each scale reveals new truths, and together they weave a picture of cosmic unity. At the smallest scale are the planetary systems. Around Andromeda's hundreds of billions of stars, planets almost certainly orbit in abundance. Though too distant to detect directly with today's instruments, the laws of probability are unyielding. If the Milky Way hosts billions of Earth-like worlds, Andromeda, with its even greater population of stars, must contain at least as many, perhaps far more. Gas giants sweep around distant suns, icy worlds drift at the edges, rocky planets circle in the habitable zones where liquid water might exist. Each planetary system is a microcosm, tiny compared to the galaxy, yet vast compared to human experience. Zooming outward, we arrive at star clusters. These are families of stars born together, bound by gravity, sharing common ages and compositions. Open clusters sparkle in Andromeda's arms, loose gatherings of young stars recently emerged from their natal clouds. Globular clusters hover in its halo, ancient and enduring, survivors from the dawn of galactic time. Together, they show the life cycle of stellar communities, from youth to antiquity, scattered across the canvas of the galaxy. Beyond clusters, the spiral arms themselves stretch across tens of thousands of light-years. They are patterns, not permanent structures, yet they shape the galaxy's appearance. Here, stars, gas, and dust align in waves of density, creating the sweeping curves we see from afar. Within these arms lie the regions of greatest creation, stellar nurseries blazing with ultraviolet light. They are the arteries of the galaxy, channels through which matter cycles from gas to stars to remnants, sustaining Andromeda's vitality. At a larger scale still, the entire disk of Andromeda emerges. More than 220,000 light-years across, it is a flat expanse of stars orbiting the galactic center, tilted at an angle that allows us to see its structure with remarkable clarity. The disk contains most of the visible matter, the stars that give Andromeda its luminous beauty. Yet even this vast structure is but a fraction of its whole. Surrounding it is the halo, a sphere of dark matter and ancient stars extending far beyond what our eyes can see. In truth, the visible disk is only the heart of a much larger, invisible body. Expanding further, we see Andromeda's role in the local group. Alongside the Milky Way, it is one of two dominant members, their mutual gravity shaping the fates of dozens of smaller galaxies. Streams of stars connect Andromeda to its companions, whispering of mergers past and future. The local group itself spans millions of light-years, yet is still a modest structure by cosmic standards. It is a village of galaxies, and Andromeda is one of its leaders. Beyond the local group lies the Virgo supercluster, a collection of thousands of galaxies stretching across 110 million light-years. Here, Andromeda is but one member of a vast community, drifting along filaments of dark matter that connect clusters like beads on a cosmic string. The Virgo supercluster is part of an even larger structure, the Laniakea supercluster, our galactic continent in the universe, encompassing hundreds of thousands of galaxies across 500 million light-years. Within this enormous expanse, Andromeda is one citizen among many, no larger in proportion than a grain of sand on a beach. And yet, the hierarchy continues. Beyond superclusters lies the cosmic web itself, a network of filaments and voids stretching across billions of light-years. Here, galaxies are nodes in a vast structure shaped by gravity and dark energy. Andromeda, with all its stars, nebulae, and history, is a single point in this lattice, no more central than any other, yet indispensable to the whole. Without galaxies like it, the web would not exist. This journey through scales reveals a profound truth: the universe is fractal in nature, with structures repeating across levels of magnitude. Planets orbit stars, stars orbit clusters, clusters orbit galactic centers, galaxies orbit within groups, groups within clusters, clusters within superclusters. And all of it obeys the same laws, the same gravity, the same physics. To understand Andromeda at one scale is to glimpse principles that apply at all scales. For us, this is both humbling and empowering. Humbling, because we see how small we are, a species on a planet orbiting one star in one galaxy among billions. Empowering, because we realize that the same physics we study here applies across the cosmos. By decoding the orbits of planets, we learn the orbits of stars. By studying the Milky Way, we learn Andromeda. By measuring Andromeda, we learn the universe. Knowledge scales, just as structures do. Andromeda's uniqueness lies not only in its size or proximity, but in its role as a bridge across scales. It is near enough to resolve into individual stars, yet vast enough to reveal galactic dynamics. It sits within the local group, yet connects us to the Virgo supercluster. It is both a neighbor and a window, both intimate and immense. When we think of Andromeda only as a distant galaxy, we miss this richness. It is not distant, it is connected, nested within the same cosmic hierarchy we inhabit. From the orbit of a single planet around a star and its disk to the flow of the local group into Virgo, Andromeda is part of a single tapestry. And in contemplating this tapestry, we come to see ourselves differently. Our scale is tiny, yet our minds can traverse all scales, from the quantum to the cosmic. In Andromeda's nested structures, we find a metaphor for our own lives, each of us part of families, communities, nations, species, ecosystems, planets, galaxies, universes. None complete without the others. None too small to matter. Thus, to journey into Andromeda is not only to explore another galaxy. It is to explore the structure of reality itself, across every level, from the intimate to the infinite. And in that exploration, we discover the unity of existence, a unity that binds planets to galaxies, galaxies to clusters, and us to the stars. When we gaze at Andromeda with our eyes alone, we see it only as pale light, a faint cloud against the night. But galaxies are not just visible objects. They are engines of energy, radiating across the entire electromagnetic spectrum. Andromeda, like every galaxy, tells its story not only in starlight but in a symphony of radiation, from the longest radio waves to the most energetic gamma rays. To understand it fully, we must listen to every note. The most obvious energy comes from its stars. Hundreds of billions blaze, each converting hydrogen into helium through nuclear fusion. In this process, mass itself becomes energy, released as light and heat. From hot, blue O-type giants to cool, red dwarfs, the stars of Andromeda span a range of temperatures and brightnesses. Their combined luminosity makes the galaxy shine with the brilliance of tens of billions of suns. If Andromeda were as close as the Magellanic Clouds, it would dominate our sky, casting shadows at night. But visible light is only part of the story. In radio wavelengths, Andromeda reveals vast structures of cold hydrogen gas. These invisible rivers stretch far beyond the optical disk, feeding star formation and mapping the skeleton of the galaxy. Radio waves also capture synchrotron radiation, emission from electrons spiraling through magnetic fields at near-light speeds. This glow paints Andromeda's disk with invisible filaments, tracing cosmic rays accelerated by supernova explosions. In infrared, the galaxy glows with warmth from dust grains. Starlight absorbed by dust is re-emitted as heat, making Andromeda shine brightly to infrared telescopes. This wavelength unveils star-forming regions hidden behind veils of dust, revealing nurseries that optical eyes cannot penetrate. The James Webb Space Telescope has peered into these regions, showing infant stars emerging from their birth clouds like embers in a cosmic hearth. X-rays tell a more violent tale. In Andromeda, as in the Milky Way, binary systems of collapsed stars devour matter from their companions. The gas spirals inward, compressed and heated until it radiates at millions of degrees. These X-ray binaries are among the most energetic objects in the galaxy, each a tiny lighthouse of high-energy radiation. Supernova remnants too emit X-rays, their shock waves energizing gas into brilliance. Together, they transform Andromeda into a patchwork of violent, flickering lights, invisible to human eyes but vivid to our detectors. At even higher energies, gamma rays emerge. Though faint compared to starlight, they tell of processes more extreme than ordinary fusion. Cosmic rays colliding with gas release gamma radiation. Pulsars beam it into space from their magnetic poles. The supermassive black hole at Andromeda's center, though less active than those in some galaxies, may also contribute faintly, a reminder of the immense energies lurking at its core. Andromeda is not only a source of light but of particles. Cosmic rays, high-energy protons and nuclei, stream from supernovae and stellar flares, traversing the galaxy at nearly the speed of light. They collide with interstellar gas, ionizing atoms and driving chemical reactions. They spiral along magnetic fields, invisible currents shaping their paths. Though we cannot see them, cosmic rays are part of the galaxy's energy budget, subtle but significant. When astronomers combine these wavelengths, a richer picture emerges. Andromeda is not a static glow, but a living engine, where calm starlight coexists with violent bursts, where cold gas radiates faintly while hot plasmas blaze. Each form of energy interacts with the others. Radiation from stars pushes on dust, sculpting nebulae. Supernova shock waves compress gas, triggering new stars. Magnetic fields guide cosmic rays, influencing how energy spreads. The galaxy is a web of feedback, energy flowing in endless cycles that sustain its evolution. Even the background radiation of the universe plays a role. Andromeda's halo of hot gas glows faintly in X-rays, heated in part by interactions with the cosmic microwave background, the afterglow of the Big Bang itself. In this way, Andromeda is not isolated but connected to the energy of the universe as a whole. Its light is not only its own but part of the grand energy flow that permeates all of space. One of the most profound aspects of Andromeda's energy is its distance. Every photon that reaches us began its journey 2.5 million years ago. The light we see tonight left before humans walked the Earth. Some X-rays we detect were emitted before the first cities rose. Cosmic rays arriving at our detectors may have been launched when ice ages swept across our planet. To study Andromeda is to study the past, not the galaxy as it is, but as it was. Every wavelength is a time machine, every photon a messenger from ancient epochs. The diversity of Andromeda's emissions also makes it a cosmic laboratory. By measuring its radio waves, we learn about cold gas and magnetic fields. By tracing its infrared light, we uncover hidden star formation. By observing its X-rays and gamma rays, we probe extremes of physics no earthly experiment can reach. In this way, Andromeda is not just an object of beauty but of science, an energy map that teaches us the laws of nature. And yet, for all this energy, the galaxy is astonishingly quiet compared to some others. Quasars in the distant universe blaze with luminosities that outshine entire galaxies, their central black holes devouring matter at ferocious rates. Starburst galaxies erupt with star formation so intense they pour out infrared light like furnaces. Compared to these, Andromeda is serene, a galaxy in balance, radiating steadily rather than explosively. Its energies are diverse, but not overwhelming. It is not chaos, but harmony, a cosmic city humming with activity rather than burning with frenzy. For us, this harmony is an opportunity. Because Andromeda is relatively calm, we can study its energies in detail, disentangling their sources without the blinding glare of extremes. It becomes a model, a baseline, a reference against which we compare more exotic galaxies. In Andromeda, we see what a mature, massive spiral looks like when it has settled into equilibrium. Energy defines Andromeda. Without fusion in stars, it would be dark. Without supernovae, it would lack the heavy elements that build planets. Without radiation across wavelengths, it would be invisible. Without cosmic rays and magnetic fields, its chemistry and star formation would change. Every aspect of the galaxy is shaped by energy, its origin, its evolution, its destiny. And when we look at Andromeda across the spectrum, we are reminded of a final truth: reality is larger than what our eyes can see. The faint blur in the night is only a fraction of its being. To perceive the rest, we must build instruments, extend our senses, expand our imagination. In doing so, we do not only learn about Andromeda, we learn about the universe, and about ourselves, as creatures who turn light into knowledge, and knowledge into wonder. Galaxies are not born as we see them today. They grow, evolve, and transform over billions of years, their shapes sculpted by gravity, their identities forged in collisions and mergers. Andromeda, with all its grandeur, is no exception. To journey into its history is to watch a cosmic organism mature, from a chaotic infancy to the spiral giant we know now. The story begins in the early universe, when the cosmos was only a few 100 million years old. Matter, seeded by quantum fluctuations in the Big Bang, had clumped into vast clouds of gas and dark matter. These were the building blocks of galaxies, proto-galactic clouds where hydrogen and helium began to collapse under gravity. In one such cloud, destined to become Andromeda, the first stars ignited. They were massive, hot, and short-lived, exploding quickly as supernovae and seeding their surroundings with heavier elements. At this stage, Andromeda would not have resembled a graceful spiral. It was turbulent, irregular, fragmented, a swarm of smaller clumps falling together. Streams of gas fed its core, while starbursts erupted in flashes of creation. The galaxy grew not as a single unit but as a gathering of fragments, merging and colliding, each encounter reshaping its form. As time passed, the first coherent structure emerged, a rotating disk of stars and gas. Gravity, always the sculptor, flattened the swirling material into a plane. Angular momentum preserved from the collapse forced matter into rotation, and the seeds of a spiral pattern began to appear. Around this young disk, smaller galaxies continued to fall in, adding their stars and dark matter to the growing giant. Each merger left scars, streams of stars in the halo, tilts and warps in the disk, asymmetries in the spiral. Andromeda's bulge, the dense concentration of stars at its center, was shaped by such events. Some theories suggest it formed from violent mergers in its early history, when smaller galaxies crashed into its core and triggered starbursts that created dense, old populations of stars. Others propose it grew more gently, as gas flowed inward and formed stars over extended periods. Today, its bulge contains some of the oldest stars in the galaxy, fossils of an epoch long past. The spiral arms we see now are younger structures. They are not permanent features but patterns of density waves, continually reshaped by motion and interaction. Yet they too tell a story of evolution. Andromeda's arms are slightly asymmetric, one stronger than the other, a clue that tidal forces from companion galaxies have pulled at its structure. Perhaps the Triangulum Galaxy, M33, played a role. Perhaps the many dwarf companions that circle Andromeda left their fingerprints in these distortions. The spiral is not a static design but an evolving response to its environment. Its halo, vast and diffuse, holds even deeper memory. Here lie ancient stars and globular clusters, many older than the galaxy's disk itself. Some of these clusters likely formed outside Andromeda entirely, in dwarf galaxies that were later consumed. Their orbits, eccentric and scattered, preserve the story of these mergers. To map the halo is to read the archaeology of Andromeda's past, each cluster a relic of a collision billions of years ago. The chemical evolution of Andromeda also reveals its biography. In its oldest stars, astronomers find little more than hydrogen and helium, the primordial elements. In younger stars, heavier elements abound: carbon, oxygen, iron, silicon, created in previous generations of stars. This gradual enrichment shows how Andromeda has recycled matter over billions of years, turning gas into stars, stars into supernovae, and supernovae into the ingredients of planets. The galaxy we see today is not the same as it was, it is richer, more complex, more fertile for creation. Even the central black hole has a story. Though now relatively quiet, it likely passed through active phases, when gas falling inward formed an accretion disk that blazed with radiation. Andromeda may once have shone as a quasar, outshining all its stars combined. Today, only a faint glow remains, but the memory of that violence lingers in the dynamics of its nucleus, in the oddity of its double core, in the trails of stars that orbit invisibly around a gravitational abyss. Every part of Andromeda bears witness to its history. Its warped disk speaks of encounters. Its asymmetric arms reveal interactions. Its halo preserves fossils of mergers. Its bulge and nucleus hold the record of ancient starbursts. And its chemical composition tells the tale of countless generations of stars living, dying, and enriching the galaxy. From a chaotic infancy to a majestic spiral, Andromeda has never ceased to change. And its evolution is not complete. In billions of years, it will merge with the Milky Way, reshaping itself once again. The spiral form will vanish, replaced by an elliptical giant. Its streams will blur into a smoother halo, its arms dissolve, its disk fade into memory. Yet even then, it will not be static. For galaxies are not monuments but rivers, flowing across time, always moving, always changing. In contemplating Andromeda's structural evolution, we see a reflection of life itself. Nothing remains as it was. Every form carries the memory of what came before, every present moment a bridge between past and future. The galaxy is not a fixed thing but a process, a story unfolding across billions of years. And in that story, we find our own. For just as galaxies evolve, so do we. Civilizations rise and fall, species come and go, planets change. We too are processes, not monuments. And in that parallel, Andromeda becomes more than a distant galaxy. It becomes a teacher, showing us that change is not loss but life, that evolution is not an exception but the rule of the cosmos. So when we look at Andromeda, we do not see a frozen spiral. We see motion. We see memory. We see becoming. We see the biography of a galaxy still being written, a chapter of the universe's great book. And though we cannot read every line, we can glimpse the arc, and in that glimpse, we find wonder. Galaxies may seem serene, their arms painted across the heavens in graceful spirals, but beneath this beauty lies violence. Andromeda is no exception. It is a stage for some of the most dramatic events the cosmos can produce, catastrophes so intense that for brief moments they rival the brightness of the entire galaxy. These rare but profound outbursts shape the galaxy's fate, enriching its chemistry, resetting its cycles, and leaving behind exotic remnants that testify to stellar death. The most famous of these events are supernovae. In Andromeda, as in all galaxies, massive stars end their lives with furious explosions. When their cores collapse under the relentless weight of gravity, the outer layers rebound outward at tremendous speed, releasing more energy in a single instant than the sun will radiate in all its billions of years of life. The blast lights up the galaxy, visible across intergalactic distances. To ancient observers on Earth, supernovae in Andromeda would have appeared as sudden stars flaring in the night sky, only to fade months later. To us, they are more than fireworks, they are factories of elements, creating iron, nickel, and gold, scattering them into space to seed future worlds. Supernovae are not all alike. In Andromeda, astronomers have observed both the core collapse variety, the deaths of massive stars, and type Ia supernovae, the thermonuclear explosions of white dwarfs in binary systems. These latter events are especially valuable to science, for their consistent brightness makes them cosmic mile markers. By measuring them in Andromeda and beyond, astronomers chart the expansion of the universe itself. Thus, Andromeda's violent deaths have contributed to our knowledge of the cosmos at its largest scales. But some events outshine even supernovae, gamma-ray bursts. Though rare, these are the most energetic explosions known, releasing as much energy in seconds as a star like the Sun will produce in its entire lifetime. They are thought to occur when massive stars collapse directly into black holes, launching jets of particles at nearly the speed of light. If such a burst were to erupt in Andromeda and point toward Earth, it would be visible even across millions of light-years. Fortunately, the chances of such alignment are slim, but the possibility reminds us that galaxies harbor dangers as well as wonders. Not all cosmic outbursts are destructive. Some are rhythmic, repeating with predictable beauty. Variable stars in Andromeda brighten and fade with regular cycles, their pulsations revealing their size and luminosity. Cepheid variables, in particular, were the key to unlocking Andromeda's distance, when Edwin Hubble measured their rhythms nearly a century ago. To this day, they serve as lighthouses of the galaxy, their steady pulses allowing astronomers to map space with precision. Other variables are more chaotic, stars that flare unpredictably, erupting with sudden bursts of light as magnetic storms twist across their surfaces. Some dwarf stars release enormous flares, far more powerful than anything our Sun produces, briefly doubling their brightness. These stellar tantrums, invisible to the naked eye but measurable with sensitive instruments, remind us that even small suns can be volatile. Around them, planets may be bathed in radiation strong enough to strip atmospheres and sterilize surfaces. Occasionally, stars do not simply explode, they collide. In Andromeda's dense clusters and crowded core, stellar orbits cross more often than in calmer regions. Though rare, collisions can occur, merging two suns into a single, larger star. The result is often a blue straggler, a star that appears younger than its neighbors, burning brightly as if defying its true age. These anomalies puzzle astronomers, but their presence testifies to the dynamic nature of galactic interiors, where even stars are not immune to encounters. Exotic remnants also leave their mark. Neutron stars, with densities beyond imagination, sometimes collide with each other, releasing kilonovae, bursts of light and gravitational waves. Such collisions produce some of the heaviest elements in the universe: gold, platinum, uranium. Andromeda, with its billions of stars, surely hosts such events. Though we have yet to detect one there directly, the laws of probability make them inevitable. Somewhere in its vastness, stars collide, elements are forged, and waves ripple across spacetime. Even planets may experience cataclysms. Though we cannot observe them directly in Andromeda, we know from our own galaxy that planetary systems are not immune to upheaval. Stars evolving into red giants engulf their inner planets. Supernova blasts strip atmospheres from worlds unlucky enough to orbit nearby. Collisions between planets or asteroids reshape systems, creating debris belts and altering trajectories. In Andromeda, these events play out on scales invisible to us, yet they must be common, shaping the destinies of countless unseen worlds. At a larger scale, entire star clusters can be disrupted. As Andromeda accretes smaller galaxies, globular clusters may be torn apart, their stars scattered into streams across the halo. Each stream is the aftermath of a gravitational cataclysm, stretched across space like the remnants of shattered worlds. These too are catastrophes, not of individuals but of collectives, stellar families dissolved into the galactic whole. The beauty of Andromeda is inseparable from this violence. Without supernovae, there would be no heavy elements. Without collisions, no new patterns of structure. Without variability, no cosmic yardsticks. The galaxy's serenity from afar hides a constant undercurrent of upheaval, a reminder that creation and destruction are inseparable. And yet, these cataclysms are not chaos. They are part of a larger order, governed by the laws of physics. Gravity dictates the orbits that bring stars together. Nuclear forces dictate the explosions that scatter elements. Electromagnetism governs the flares that brighten and fade. Even the most violent events follow rules, and in those rules lies beauty, the universe expressing itself through drama, through extremes. When we contemplate Andromeda, we must remember that its light is punctuated by these moments of brilliance and destruction. Every few centuries, a supernova lights its skies. Every few millennia, a neutron star collision enriches its matter. Every day, countless stars pulse, flare, or evolve in silence. To study Andromeda is to witness not only constancy but also change, not only harmony but also eruption. And in this, we find reflection. For life too is punctuated by cataclysms, extinctions, upheavals, revolutions. From them, new forms arise, new possibilities open, new futures unfold. The universe, in all its scales, follows the same pattern: creation born of destruction, beauty born of violence, order born of chaos. So when we look at Andromeda's faint glow, we should see not only a galaxy of steady stars but also a galaxy of rare catastrophes. Each one is a spark in the great narrative, each one a chapter of drama written across billions of years. And though we may never witness them all, we know they are there, waiting, unfolding, shaping the destiny of a galaxy and, by reflection, teaching us the destiny of our own. The Andromeda Galaxy is already a familiar presence in our sky. We have charted its stars, measured its rotation, mapped its halo. Yet in truth, our study of this neighboring giant has only just begun. The instruments of today are windows, clearer than those of the past, but still narrow. The future promises more, sharper vision, deeper reach, and tools powerful enough to transform a faint smudge of light into a detailed portrait of another universe of worlds. The first revolution will come from ground-based telescopes of extraordinary scale. Already, projects are underway to build mirrors tens of meters across. The extremely large telescope in Chile, with its 39-meter mirror, will resolve stars in Andromeda with unprecedented clarity. It will pierce its crowded clusters, separate individual suns from the blur, and reveal planetary systems through the subtle wobbles of starlight. Instruments like this will turn Andromeda from a distant glow into a map, charted star by star. But the ground has its limits. Earth's atmosphere blurs and absorbs, scattering the light that reaches us. Space-based observatories will extend our reach. The James Webb Space Telescope is only the beginning. Future telescopes, with mirrors larger than houses, will orbit far from Earth, free from distortion, watching Andromeda in wavelengths invisible to our eyes. Ultraviolet observatories will trace its hottest, youngest stars. Far-infrared missions will unveil its coldest gas clouds. X-ray and gamma-ray eyes will catch its most violent eruptions. Together, they will weave a complete tapestry of energy across the galaxy. The most ambitious plans look to the edges of our solar system. At vast distances, the sun's gravity acts as a natural lens, bending light from distant objects and focusing it at a point hundreds of billions of miles away. A spacecraft placed at this gravitational focus could, in principle, image planets in Andromeda with resolution unimaginable today. We might see oceans glinting on alien worlds, clouds drifting across continents, or even the spectral fingerprints of life. Though still in the realm of theory, such missions show what may be possible if humanity endures. Closer to home, technologies of analysis will grow just as powerful as the telescopes themselves. Artificial intelligence will sift through oceans of data, detecting patterns too subtle for human eyes. Variations in starlight, too faint for us to notice, could reveal exoplanets orbiting suns in Andromeda. Spectra smeared by distance could be disentangled, showing atmospheres with oxygen, methane, or water vapor. Each detection would be a message across the void, proof not only that other worlds exist, but that they are alive with chemistry familiar to us. Even without direct detection, signs of habitability may be within reach. The combined light of billions of stars carries whispers of planets. Statistical analysis can reveal their abundance, their sizes, their likely compositions. Already, in our own galaxy, surveys show that planets are common, not rare. In Andromeda, the same must be true. The difference is only distance, not principle. With better instruments, the probability will shift from assumption to certainty. Beyond planets, the future of Andromeda studies lies in time itself. Long-term monitoring will capture changes invisible in short snapshots. Over decades, we may watch stars brighten, fade, or explode. Over centuries, we may see clusters shift, streams stretch, or new nebulae ignite. Though human lives are brief, the continuity of science allows us to build time-lapse portraits across generations. For Andromeda, the future observers of Earth will provide the next frames of a movie billions of years long. The possibility of interstellar, or intergalactic, probes lies even further ahead. For now, the distances are beyond our reach. But concepts like light sail craft propelled by lasers suggest that tiny probes could, in theory, one day leave our galaxy. Their journeys would span millions of years, but time is not the enemy of machines. They could drift patiently across the void, carrying with them the curiosity of humanity, arriving at Andromeda long after our civilizations have changed, perhaps even long after Earth itself is gone. Andromeda may also become a beacon for communication. If life exists there, intelligent or otherwise, its signals may cross the gulf in radio waves or light. We, too, may send messages, beams of information encoded in photons, shouting across 2.5 million years of travel. The conversation would not be dialogue in the human sense, it would be a correspondence of epochs. Yet even the act of sending would mark a milestone, proof that one civilization in the universe dared to speak to another galaxy. Philosophically, the future of Andromeda studies is more than science. It is a reflection of humanity's persistence. Every telescope built, every photon analyzed, every mission imagined is an act of faith, that knowledge is worth pursuing, even when distances mock our reach. Andromeda does not promise us answers quickly. It demands patience, humility, and vision. But in return, it offers something priceless, perspective. For what does it mean that we, on a small planet orbiting a modest star, can imagine imaging oceans on worlds in another galaxy? What does it mean that we can calculate orbits, predict collisions, and measure the faintest energies from millions of light-years away? It means that intelligence is not bound by scale. That awareness, once born, can leap across space in thought, even if not yet in body. And perhaps that is the true future of Andromeda for us. Not that we will ever colonize it or walk its worlds, but that it will forever expand our imagination. It will remain a canvas on which we project our deepest questions, our boldest hopes, our most audacious dreams. And in doing so, it will continue to shape us, just as much as we study it. The faint blur in the night sky will become, with each generation, more vivid. From a cloud, to a galaxy, to a collection of stars, to a multitude of worlds. Each layer peeled back by science, each revelation deepening the mystery. The journey to Andromeda is endless, not because of its distance, but because of the inexhaustible curiosity of the human mind. And so, as we look ahead, we know this: the Andromeda Galaxy is not only our neighbor, not only our future collision partner, not only a laboratory of physics. It is also our destiny as observers. We are bound to it not just by gravity, but by vision. It will always call us to look deeper, to build better, to imagine further. For the galaxy is not static, it evolves. And so do we. And in that shared evolution, across light years and ages, we meet in the space between starlight and thought, where curiosity itself becomes the bridge across the void. For most of history, Andromeda was not a galaxy. It was a story. Before telescopes, before astrophysics, before the word universe had its modern meaning, the faint smudge in the sky was woven into the myths of ancient peoples. The Greeks placed it in their constellations, naming it for Princess Andromeda, daughter of Cassiopeia, chained to the rocks as sacrifice to a sea monster. To them, the hazy light was not a collection of suns, but a jewel in the story of gods, heroes, and monsters. Other cultures saw it differently. In Persia, it was known as the little cloud, a soft glow in the heavens that stirred poetic imagery. In medieval Islamic astronomy, scholars catalogued it carefully, preserving knowledge that would later inspire European observers. To the Chinese, who tracked the heavens with meticulous care, it was one among many misty patches catalogued in their records, evidence of a sky alive with subtle detail. Each culture interpreted the blur in its own way, but all agreed it was something special, a light not like the others, a mystery in plain sight. As science advanced, Andromeda began to shift from myth to object. When telescopes revealed its structure, artists and thinkers reimagined it. In the Romantic era, writers and painters portrayed nebulae, including Andromeda, as symbols of the infinite, metaphors for mystery and eternity. Poets compared them to clouds of thought, painters placed them in cosmic landscapes, philosophers used them to illustrate the sublime. To see Andromeda through early glass was to see infinity condensed, a vision that inspired awe and humility. The 20th century transformed Andromeda from symbol into revelation. When Edwin Hubble proved it was another galaxy, humanity's imagination exploded. Suddenly, the universe was not confined to the Milky Way but expanded into countless island universes. Andromeda became the emblem of this discovery, the gateway to the realization that the cosmos was far larger than we had ever dreamed. Newspapers reported it with astonishment, artists reimagined humanity's place, and science fiction writers seized the idea that other galaxies could host alien civilizations, new worlds, new futures. Indeed, Andromeda has long been a favorite stage for imagination. In literature and cinema, it appears as the home of distant species, the setting of intergalactic wars, the origin of mysterious signals. The very name, Andromeda, carries poetic weight, at once familiar and exotic, grounded in myth yet expanded by science. From pulp magazines to Hollywood blockbusters, the galaxy has served as a backdrop for human stories projected across cosmic scales. It is a reminder that the line between science and fiction is often blurred by curiosity. In art, Andromeda is a muse. Painters have depicted its spiral arms with strokes of light, photographers have captured it in breathtaking astrophotography, musicians have named symphonies and songs after it. Its beauty is not only in its science but in its ability to inspire. The faint glow visible to the naked eye is a connection across time. Ancient poets, medieval scholars, modern scientists, and ordinary stargazers have all seen it, wondered at it, and woven it into their own narratives. As a cultural symbol, Andromeda also speaks to scale and humility. It is often invoked as a reminder of how small we are, how brief our lives compared to galaxies. Yet it is also invoked as a reminder of possibility. If another galaxy exists so near, filled with billions of stars, then surely we are not alone. In this sense, Andromeda has become a symbol of both humility and hope, a balance of cosmic insignificance and cosmic connection. In the modern age, Andromeda appears in classrooms and documentaries as the archetype of a galaxy beyond our own. Children learning of the universe see it as the nearest great neighbor, the other against which we measure ourselves. Scientists present it as the key to understanding galactic evolution. Philosophers use it as an image of the unreachable, a metaphor for goals beyond immediate grasp. And everyday people, looking up on dark nights, can find it with the naked eye and feel, for a moment, that they are connected to the cosmos in a direct and personal way. The cultural journey of Andromeda mirrors our intellectual journey. From myth to science, from symbol to subject, it has grown with us. And it continues to grow, for its meaning is not fixed. In the future, as our instruments improve, as we perhaps detect planets and even biosignatures within it, Andromeda will shift again in human imagination. It will no longer be only a distant neighbor, but a place, mapped, studied, perhaps even messaged. The myths of tomorrow may not be about chained princesses or sea monsters, but about civilizations under other suns, sharing the same galaxy in spirit if not in body. Andromeda's place in culture also teaches us something profound about ourselves. We project onto it our fears, our hopes, our stories. We make it a mirror, seeing in its faint light the outlines of our own imagination. It is at once real and symbolic, factual and mythical, scientific and poetic. That duality is not a weakness but a strength. For it shows that the universe is not only to be measured, but to be felt. The Andromeda Galaxy is not just a cluster of stars. It is a chapter in humanity's imagination. It is the blur that became a myth, the myth that became a mystery, the mystery that became a revelation. It is a reminder that knowledge does not diminish wonder, but deepens it. That science and culture are not enemies, but companions. That the universe can be both a fact and a poem. And so, when we look at Andromeda, we are not only astronomers, but storytellers. We are inheritors of myths and creators of new ones. We see not only what is, but what could be. And in that act of vision, we make the galaxy not only part of the cosmos, but part of ourselves. The Andromeda Galaxy is not only a celestial object. It is a mirror of our destiny. To study it is to study the forces that shape us, the futures that await us, and the meaning of being conscious in a universe that rarely notices itself. For humanity, Andromeda is both a neighbor in space and a companion in imagination, a destination unreachable yet always present, a symbol of what lies beyond. As our civilization advances, our relationship with Andromeda will deepen. Today, we observe it through telescopes. Tomorrow, we may observe it through constellations of orbital observatories, vast networks of sensors spanning the solar system, coordinated to act as a single eye. Beyond that, we may deploy instruments at the gravitational lens of the Sun, turning spacetime itself into a telescope. In time, we may even send probes, tiny messengers launched not for immediate return, but for journeys lasting longer than civilizations, longer than planets, perhaps longer than Earth itself. Andromeda also offers us a perspective on survival. Our sun will not last forever. In billions of years, as it swells into a red giant, our descendants will need new homes. Perhaps they will find them among the stars of the Milky Way. Perhaps they will travel further, across the intergalactic gulf, toward Andromeda. Though the distances are staggering, the thought itself is transformative, that humanity could one day spread beyond its galaxy, that our story might intertwine physically as well as symbolically with our nearest giant neighbor. Even if no human or machine ever crosses that gulf, Andromeda will shape our philosophy. It reminds us that permanence is an illusion. Stars die, galaxies merge, even universes change. What endures is not form but process, not structure but story. The galaxy teaches us that transformation is natural, that endings are beginnings, that beauty lies not in stillness but in motion. For some, Andromeda symbolizes solitude. It is distant, unreachable, silent. But for others, it symbolizes connection. For in its light, faint though it is, we see the same elements that make us: hydrogen, helium, carbon, oxygen, iron. Its stars burn by the same physics as ours. Its planets, if they exist, may share oceans, mountains, skies. In contemplating Andromeda, we see that we are not separate from the cosmos, but continuous with it. As our science grows, so too will our stories. New generations will see Andromeda not as a blur, but as a place, mapped, catalogued, detailed. They may know its clusters by name, its nebulae by image, its stars by spectrum. They may tell stories not of myths and monsters, but of biospheres and civilizations. Perhaps they will dream not of chained princesses but of unchained futures, futures that stretch not across continents, but across galaxies. And so, what role does Andromeda play in the ultimate arc of humanity? It is our reminder that the universe is vast but knowable, humbling but inviting, indifferent but beautiful. It is our partner in the cosmic dance, destined to merge with us in a future long after our Earth is gone. It is our teacher, our mirror, our inspiration. Our journey to the center of the Andromeda Galaxy has carried us through scales of time and space, through science and myth, through the violence of supernovae and the calm of ancient stars. We have seen its arms and its core, its clusters and its halo, its dark matter and its luminous energy. We have traced its history from chaotic birth to mature spiral, and projected its future into the collision with the Milky Way and beyond. We have felt its presence not only as astronomers, but as storytellers, philosophers, dreamers. And what have we learned? That galaxies are not still, but alive. That they are not eternal, but evolving. That they are not foreign, but kin. Andromeda is not out there. It is part of us, and we are part of it, bound by the same laws, built of the same matter, illuminated by the same light. In the end, the Andromeda Galaxy is both destination and metaphor. We may never reach it in body, but we have already reached it in thought. We may never touch its stars, but we have already touched its meaning. Its faint glow across our night sky is a bridge, not of matter, but of imagination. And as long as we continue to look upward, to wonder, to seek, the journey will never end. For the true center of Andromeda is not a place in space, but a place in us, the point where curiosity meets infinity, where awareness touches eternity, where a species on a small world realizes that it is part of something vast, beautiful, and unending.